Hello. In this demo, I will be displaying how you can use a Neue Labs hardware in combination with our desktop playground application to create a connected solution where we collect some data from the hardware and are able to display that on a single-page web application. So starting with looking at my camera, you can see our A2 device, currently hooked up with a battery, and to my computer through USB for debugging purposes. The A2 device is a small chip, about the size of the end of my pinky. It has some basic processing capabilities on board, as well as a basic suite of sensors. Today we'll be mainly using the temperature humidity sensor, but also the accelerometer. The A2 device is connected to a smartphone, which I have laying out a camera, over Bluetooth, and the smartphone is in turn connected to the internet over Wi-Fi. Any communication that we use from the desktop application and the device will be going through that connection today. Moving over to my desktop here, we can actually see the playground application, more specifically the project page of the playground application. Here you have some alternatives. You can either import a project from the cloud, open it from a folder or file, create a new project based on a template, or select an already existing one. For this demo, I have created an already existing project, which we can enter by double-clicking. This will take us to the actual editor. Playground is a low-code, node-based programming application where you can define both the behavior of websites, web applications, as well as actual hardware logic. So today we'll be doing a bit of both, starting with our web components tool. Now, with this tool, you can actually build a full web application. In this case, we'll be building a web application that we'll use as a dashboard to display some of the data that we collect from the hardware. Here in the middle, you can actually see the node editor itself. On the right, you have a preview of the website. And on the left, you have some simple project structure. I have already defined a page that contains a colored circle, a text box, and 2 line charts, one for temperature and one for humidity. I also have some of these purple patches to connect us up to our MQTT broker that is hosted on our server. Moving over to the playground tool, we can actually define logic that will run both on the chip device as well as on the phone. So I have divided these up into 2 different components that do 2 different things. Mainly the device will just be collecting data from the sensors, the accelerometer/gyroscope and the temperature humidity. It will output this data to the phone over the Bluetooth connection, which we can see in these outputs right here from the device component. We can then use this data to construct JSON objects in combination with a timestamp, which we then can push over HTTP to our MQTT broker. And from the MQTT broker, we can of course listen in from our web application. Now, if we go over to our device flows, we have an option to actually push this flow to a device. Now, I know that the device laying on my table right here is the Automat with an ID ending with 51. We can select it, and we can press push to device. Now, after a second, the flow should be loading onto the device, and it should start pushing data to the broker. There we go. So as you can see, we have data points for temperature and humidity, timestamped at the time that it was sent. We also have a text box representing the latest value that we've received. Now we can do some simple expansions on this, for example, using our AI tools. We have a text box up here in the editor where you have a couple of different alternatives. For this time, we can perhaps change the color of the circle based on the temperature value we have. So what we can do is write a prompt. Giving it a moment to generate, we'll actually receive a new node with custom JavaScript. We can open it in an editor like this and see what it came up with. And we can see here that we take a temperature value as an input. We do a comparison, and if true, we send that as one output. Otherwise, we send it as another. Now, we can easily hook this up from our telemetry patch that receives the temperature. We can say to connect the temperatures from output to input. And then we can take that, and on true, we want the circle to be red, and on false, we want it to be blue. Now we can actually see in these arrows how the data flows. And since we're below 28 degrees, we'll have a blue circle. But if I were to cover the device, it should heat up a little bit. We can see both on the line chart that the humidity and temperature is rising. And as we get past 28, the circle turns red. Now, we can also do some basic expansions on the device side of things. We can, for example, use its LED light to represent the same thing. In our list of nodes, we simply select the RGB LED, add it to our flow. We can also use a compare. We'll write in 28. We'll take the temperature from the sensor and use it as input. And simply connect up greater than to red, smaller than to blue. If we then push this to the device, let it take a second to update, we see a blue light. And if we look back on our web application, the circle is also blue. Now, to do our trick again to heat it up, we have a red circle, and indeed, the LED turned red before going down to blue again. So, this is the end of the demonstration for our connected solution. Thank you.